Hi, my name's Alex Williams, founder of the New Stack, and you are listening to the New Stack Analyst podcast, a show about application development and management at scale. Thanks for joining us. These days, performance defines the success of an application. Teridion offers a new approach at how to get great performance with a new take on dynamic content delivery. Teridion makes files upload faster, web conferences run smoother, videos stream quicker, and applications pop, making your customers very happy. You can learn more at Teridion.com. That's Teridion.com. Hey, it's Alex Williams of the New Stack here for the New Stack Analyst Show. Today we are talking with Teridion, and the focus of our discussion is on easing the pain of latency when scaling applications. David Ginsburg is the Chief Marketing Officer at Teridion. We're also joined by Jim Davis, a Senior Analyst at 451 Research. Hey guys, how are you?
Doing good, thanks.
Good, thank you.
Great. Dave, why don't you tell us a little bit about Teridion? You're the sponsor for this podcast. Thank you very much for that. And we just would like to hear more about the company and what your approach is to this latency issue.
Sure, and thanks. We effectively make the public internet faster. And the background there, if you look at the increasing deployment in the public cloud, more and more content and applications moving to the cloud, we see the need, and in fact our customers and their end users see the need for a more effective way of delivering their content. And given some of the issues with the public internet, with peering, with latency, delay, packet loss, we see the need for doing this at the cloud provider layer. In order to do that, you have to deploy monitoring, which will inform a management system as to which are the best paths, which paths are least congested or giving you the highest throughput. We can send our users traffic over those paths, and because of that, they get better performance. We sometimes, or I should say some of our customers, describe us as Waze for the internet. And if you're familiar with Waze as a car navigation system, that's actually a pretty good analogy.
Well, how does Waze, what's the analogy for Waze and latency?
Sure. So if you look at, how long latency it'll take you to get from one point to the other. If you say you're in the Bay Area and you have multiple ways you can get between San Jose and San Francisco, the navigation system, by using all of these, tens of thousands of probes, which are your cars, that knows which highways or roads are faster, which highways or roads are slower, and it can direct you on a road that's going faster, a road that's in effect providing lower latency.
Great. Jim, you've been studying this market, and I know you guys work with Teridion too. Tell us about what's happening in the market as far as this transformation that we're seeing, with CDNs and networking. We at the New Stack, we write a lot about, the New Stack and how it relates to application development and management at scale. And, but we don't really touch on those issues that are kind of the intangibles, right? How do you actually manage, the speed and performance of your application? And that seems to be the critical issue now. Is that from your perspective, is that a driver for why we're seeing, more companies like Teridion? Perhaps you can talk about how, why there is this transformation. For example, with CDNs, with this new kind of networking, and what is that transformation looking like?
Well, yeah, I think you absolutely do see a need for developers to understand what's happening to their application, because when it used to be the case that you developed something, it was only going to run in this constrained environment. There's only X number of users that were going to use it, and you could really easily figure out who was going to do that, how many people were going to be using something. With applications being more internet-oriented or cloud-oriented, I guess we could say, latency and other issues come into play a lot more, and the problem is it's hard to keep track of them. Things are always changing. Now are we not only able to scale our applications, automatically in the cloud, but we have to do that according to what's coming in from the outside. And we don't have, well, certainly over time you can get a sense of how many users are going to come in at a given time of day, but we still have the unexpected flash crowd problem. That's something that CDNs have actually been addressing for a long time. It's just a matter of, we're finding different ways that we can use CDNs and overlay networks type technologies to deal with latency. Well, latency just being one part of a performance issue. I think we wind up seeing developers trying to address both performance, security, and availability as this kind of a nexus of issues. And sometimes, some of these techniques that we're using in terms of performance through a CDN can also help us in security. We see CDNs increasingly adding on services such as DDoS and web application firewall protection, because when you have distributed resources, what you wind up being able to do is also stop bad requests from coming into your application. And so we see a lot of different ways in which that market is evolving. And then I guess at the enterprise level as well, we see cloud impacting how network resources are allocated. And there's a lot of demand and need for much more flexible allocation and management of the network, both the enterprise WAN as well as things that are beyond that, the internet. So there's still a lot of room for companies like Teridion and others to come in and find clever ways to help monitor and manage performance of applications, even with all of these variables out there.
So one of the things that you really notice, at least from our perspectives, when you compare, for example, traditional IT and the way that IT had been managed, 5-10 years ago, versus today, what you're seeing, for instance, with cloud services, is this kind of concept of downtime. Downtime doesn't seem to be as much of an issue anymore. It's everything seems to be up all the time, but you can be waiting forever for whatever it is you're doing. So we've all had that experience almost on a daily basis, and so it becomes that latency is really is really that new downtime. And so, Dave, I'm curious. You guys talk about this idea of the quality of experience, and what does that mean? And what does that mean for the developer who again is trying just to create these applications and that don't just get don't get stuck in traffic, so to speak.
Sure. So if I look at quality of experience, called QoE, we want to look at vertical by vertical because it differs, and it'll differ if you're doing something, for example, going to a newspaper's webpage that is really only downloads, or doing a video conference, or a VoIP session, or, for example, you're doing a financial trade from your mobile phone. And what happens there is the application developer needs to understand what contributes to latency between where they're delivering their service, we call it the origin server, their data center, obviously working in the cloud now, and the end user, wherever they may be in the world or in whatever device they're on. And to give a good example, ad serving. And we have one customer, Quixie, who their claim to fame are deep application and ad cards that get embedded in other people's sites. But if you look at ad serving in general, it's a very complex environment between the advertiser, the buy side, the sell side, and ultimately the end user. And there are multiple places where delay and packet loss can occur. And to give an example, what we were able to do is change or really decrease the latency between the end user and the sell side from over a second to about 350 milliseconds. And so the question is, what can be reduced to make that happen? You have to really decompose the end-to-end transaction. You look at the DNS lookup, you look at the initial request, you look at the wait at the server, you look at responses, you look at final rendering, and the application developer can say, wow, this I can influence, this I can't influence, this I can work with, say, a company like Teridion to help reduce. And this really deterministic way of looking at bettering the quality of experience has to happen at each point across called the application delivery chain, each part of it, and you have to have an understanding of whether it's network related, whether it's server related, whether it's client related, and try your best to optimize each and every segment.
So you talk about determinism. We're hearing that concept, more often now. Can you explain that a little bit more? What that approach is?
Sure. So I'm an application developer, and I want to deliver a certain quality of experience. And that can be an ad serving network where you want to deliver it in less than half a second. It can be, for example, we have a customer called Leverate who has their financial servers in London, but they wanted to be able to serve customers in China. And they want to ensure that the Chinese customers have a good mobile trading experience. In the same way, you're Netflix. And if a person has say a cable broadband service that is capable of delivering 4K, you want to make 4K available to them. So you understand what user experience you want to provide to the end user. They're obviously paying for that user experience, and you want to understand which each element of the delivery chain from the client to the origin server adds to that, impacts that, and you want to do your best to really eliminate the latency, eliminate throughput bottlenecks, eliminate packet loss at each and every point. So that really gets into these issues around performance, and we heard that your approach to kind of taking almost taking these markers and to looking at kind of like all these routes, and again it relates back to that Waze analogy. Jim, I'm curious about quantifying performance, and how are you seeing the end users trying to quantify performance, and how does that correlate to companies like Teridion?
Well, so one of the important things that you brought up, and we hadn't really said yet, is there's a distinction between quality of experience as opposed to quality of service. We'll all have our own definitions of it, but quality of service to me is different. It's perhaps a more engineering-centric view of quality, and it's measured by whether something was delivered, or even just if enough was delivered for a service such as voice over IP to be usable. Quality of experience, on the other hand, I think is a more user-centered view of whether or not something is usable. An area where this term started to gain traction really was in online video and IPTV. The idea of measuring quality of experience was to figure out if the video was being viewed at HDTV quality, for instance. The thing with video is that video compression works by sending key frames and then sending information about how that frame is changing. So if you think of it as a form of deduplication, not sending redundant visual information that takes up bandwidth, you see that quality of experience is about actually viewing the video and not just quality of service, where the terms might be met by a network, but if it sent the wrong packets or the wrong packets were dropped, the reference frame in this case, then the viewer gets a blue screen and rebuffering and frustration, even though, again, the quality of service terms were met. So QoE is about measuring network and application level performance that is relevant to the end user's perception of whether or not a service is functional.
That's fair. I think it's very semantic, doesn't it?
Well, yeah, a little bit, maybe too much, but I was shorter than Robert Pirsig in Zen and the Art of Motorcycle Maintenance.
So Dave, it's interesting kind of a question about these semantics and what is actually the experience that actually you should be striving for. How, for your own customers, how do you quantify that performance? And providing kind of that almost that semantic kind of view of things, so people can feel comfortable, not according to some quality of service standard.
Sure. So, we use the word semantics again because in some cases, or I want to say in really all cases, there's both the subjective and the objective that our customers are requesting. In the case of some of the customers I mentioned, they had set goals as to what delay, what latency across the network they felt was required to deliver their service properly to their customers, and that would obviously impact retention and impact the bottom line. In other cases, it is a little bit harder to quantify. For example, if you're a file sharing and synchronization company like a Box or Ignite, and you're delivering service to different regions in the world, you may not have an absolute metric as to, well, the service has to be 10 times faster or 5 times faster or 20 times faster, but you just want to deliver what the user would perceive as a premium experience as compared to your competition. So really the short answer is we have to go into a given customer, giving them actual metrics and showing X% performance improvement versus the generic internet, but there's also the subjective as well.
So it does bring into questions. We talk about this more often now, like these changing constructs and these identity these different kinds of views on identity. And I think of topics such as I was just doing some research on this market, and there's been terms we've heard a long time, like provisioning and managing capacity. Is that enough in this day and age, Jim? Are these the kind of terms that we're starting to see replaced by other terms? And how does it reflect on kind of these new constructs that we're seeing emerge?
Well, I guess if we thought of, again, this previous era of application development, managing the quality of the experience was easier, although it still had its own struggles. We had to provision and manage hardware and network capacity based on our best guesses, and it was something that the company had to invest in beforehand without really knowing for certain what was going to happen. So certainly we have to pay close attention to provisioning server storage and cloud resources still. You don't want to stumble out of the gate and be unavailable to your customers with your application. And primarily here I'm talking about cloud-based applications. It's also difficult to project growth rates, fiscally difficult to simply spend big on infrastructure and not have customers use a service. So we've had cloud infrastructure as a service help us address that scalability problem. And if the application is architected well enough, we can move it around or replicate it, do certain things to move it to different regions to start to address the latency issue. But we don't necessarily get all the way there with solving latency issues because of all these pesky little networks that lie in between, which would have their own performance characteristics. Is the end user on a mobile network? Which kind of mobile network? Are they on China Unicom versus a different network in China? Accounting for all of those differences becomes a really hard to manage problem. CDNs have been around for a long time, trying to help solve both scalability and latency. They move the content closer to the end users, and then the developer can leverage their compute and network resources of the vendor to handle the scale issue. That's not to say that that's the only way to do it. We're looking at people offering interconnection as a service in essence. Instead of moving my application to a different cloud provider, I'm connecting to the cloud provider that's in the same data center, and I'm doing that programmatically through an exchange platform. So those are some of the things that people are trying to leverage in order to address both scalability and latency.
So it really does require, this deeper visibility, because you can think of it, almost as like there's almost any number of factors that can affect these latency issues for an application developer. Maybe how they architected the application, and maybe, it may be just due to some other type, form of congestion. I'm curious, how does Teridion provide this granularity in analysis? Can you help the end user, for example, understand if maybe there's something in how they've architected the application that's causing issues, or is it more about the delivery of the application itself and how it's behaving across the network?
So there's really two parts of that. Let me go into visibility, and sometimes you'll hear us say that visibility without being able to take action on it is pretty useless. And what I mean by that is there are a number of tools out there that'll tell you what the loss is at internet peering points, that'll tell you where there are BGP failures, that'll tell you, which data centers are down. But in most cases, or in almost all cases, that's all they tell you. And that's little solace when, a customer calls in and they say, well, I've got crummy, application service between, Chicago and Seattle. And you tell them, yeah, we hear that from everyone. You're not alone. That makes me feel really good. And so we needed to take a different approach where you move things up to the cloud layer, because that's where your services are. That's where your applications and databases are being delivered from. You can put out, monitoring points across all of the cloud operators, and not only will they tell you what is going wrong or what is going right with the global internet, but at the same time, you need to be able to deploy the forwarding agents, in our case, virtual routers, that will allow you to take action on that intelligence. So that goes into the second point. Once you have this infrastructure in place, you can look at how that application is performing across a more optimized path. It goes into what I said a little bit earlier, and you say, well, I've been able to optimize the DNS interactions. I've cut 250 milliseconds off of it. I've been able to optimize the upload or really the request and the response, cut another 500 milliseconds off of it. And what I'm talking about here is, in fact, a case of users in India talking to the West Coast of the United States. And then you're left with, say, 250 milliseconds that is really server-side delay. And the question is, what can the application developer do there to further optimize the user experience? So what we see then is an environment where we can do a lot to optimize any uncertainty in the network part of the path, and that will then allow the application developer to better understand what they have to do at the origin server and what they have to do at the client.
Let's take a quick break and then get back to the show. These days, performance defines the success of an application. Teridion offers a new approach at how to get great performance with a new take on dynamic content delivery. Teridion makes files upload faster, web conferences run smoother, videos stream quicker, and applications pop, making your customers very happy. You can learn more at Teridion.com. That's Teridion.com. Now let's get back to the show.
One of the things that we really see, in writing and studying this market, we see a lot of, issues, surfacing around monitoring, right? And monitoring is is something that can be done, on a per location basis, so to speak, but when you start, for instance, you can monitor your applications in Amazon Web Services, for instance. But how do you, Jim, what are you seeing as the different ways people are thinking about how you translate monitoring to a global level, really, for those end users? Because this seems to be like this is where we're going, really. This is where the market is going to be increasingly about monitoring, because as we well know, we're starting to see the proliferation, for example, of microservices, right? And those are all component based. So you need to start thinking about the monitoring of the components. How do these issues apply to what we're talking about here?
Well, I'll try to think about where to start with that one. Monitoring is critical, and it's but the thing that we have is the market evolved in these little silos itself that sort of reflected how we built applications. So we would have tools for monitoring, what's going on with our servers, tools for monitoring what's going on with the application, and our own network. But then again, we turned things around more outward and started looking at making all of these services available over the internet. And so now we still have lots of applications, or even monitoring as a service for these different parts of the stack. But the thing is that there's all of these interactions between network and server and storage and all these, and the end user. As Dave is alluding to, these all add up to a certain level of latency and impacts us performance-wise. Tying all of those things together is hard to do, but it's crucial for getting the bigger performance picture together. Then, of course, as you're saying, now extend that out globally. So measuring globally what's happening with end users, there's an array of testing and monitoring tools, software and hardware that you can install. You would have services doing synthetic testing against your infrastructure. And more often now we're seeing the inclusion of RUM tools, bits of code in an application or a browser that help us get the understanding at the device level, the user level view of what's happening on the network and the device. We've seen startups cropping up in that area just focused on mobile network performance and providing monitoring and enhancements. So what Dave's talking about, we've seen some other companies talking about it too, is, we've got all of this data on a global basis, say from a CDN or from some other source, a global monitoring source, and that's great. Now let's tie that into something that can help the application perform better. Whether we're going to redirect the request to a different server or a different CDN, how do we use that information and make it easy to use, make it programmatic, taking that data that we have now and leveraging it to automatically improve the performance of the application.
So Dave, tell me about some of the experiences tell me a little bit about your customers and what they're doing and what they've, and what they're experiencing, and, to talk about the different ways which you're, working with them, so their SaaS application, so their SaaS platform or their collaboration application, it can perform at this level, and developers can be confident that, that they're building something that's actually going to have a rich user experience?
Sure. So as I mentioned, there are certain, different verticals that we're going after right now with regards to our customers and customers that have actually, deployed our services in live environments. The enterprise file sharing and synchronization side of the market is almost easier to characterize. The performance analysis we've done for that is rather straightforward. We, in fact, use Catchpoint. You alluded to synthetic measurement tools. We just compare performance over the regular internet, regular public internet versus the Teridion infrastructure. And then that is, call it the proof of the pudding as to what the performance improvement. And then in all cases, the customers have their internal tools they use to, it's called trust but verify, the old word, or the old adage. It's more interesting when we get into the low latency environment, the type of tools we have to bring to the table, and what the expectations are. And we're still learning a little bit there. I mentioned Quixie as one customer.
Right.
That's done with some of the traditional website waterfall tools, if I can call it that, and some of the internal tools that they use to verify client and server interactions. We're getting into the video and voice conferencing space. It's another set of tools that we have to bring to the table. In that case, we've been using Thousand Eyes, and we've been using Ixia, and I'm sure there's other tools that will identify that will help show the performance improvement and help us work with the application developers to better optimize the application performance. In fact, we've seen environments or we've seen instances where the application was built, the application was deployed, but the developer, for one reason or another, didn't really run a rigorous set of tests against one or more publicly available tools. Maybe they just thought, well, I'm throwing this application out onto the internet. Whatever happens, happens. And we go back to them and say, no, let's look at how your application's behaving. Let's look at how we can optimize it. And it's really an aha moment for them.
And so that aha moment is just, you actually kind of, what is it that you show them so they get that aha moment?
We can show how an application behaves. Say it's a client they've deployed on Android or iOS, and it's interacting with the server in London, and the different parts of the whole interaction between the client and the server. It goes back to what I said. What parts of it may be able to be mitigated by a better network architecture, other parts of it mitigated by a better server client-side architecture, and a lot of their focus may have been on developing the application itself and the graphics and everything like that. And now we can actually go in and help them, I'll use the word, clean up the application.
But there's really not much you can do, when they're building the application. That's really up to them, isn't it?
No, that's up to them. But this is after the fact.
Right. Exactly.
Yes.
So we're talking about networking, and some of the reading I've done is kind of discuss this issue of overlay networks and and their role in scaling. Jim, what is the role of overlay networks in the context that we're discussing here? And maybe you could help us understand exactly what overlay networks are for people who may not be familiar with them.
Well, I guess in general terms, you would think of overlay networks as a management layer or a set of resources along with that management layer that connect different networks. The internet itself, of course, is a network of networks. It's interconnecting lots of different resources together. The issue is managing how things get delivered across those different networks, right? So a CDN is an example of an overlay network. It's not exactly the same realm we've been focused on here, but they've been critical in helping scale delivery of things like online video for big audiences. We think of things like the Olympics that are coming up. We have a whole different world of options now for viewing competitions because we can stream video feed from another country, and because the CDN's resources are positioned at all of these different network junctions, millions of people can access it all at the same time, view it with the same quality that they would get on their broadcast TV.
Okay. How does it, so from the Teridion perspective, what are the role of, these overlay networks?
Sure. The analogy I sometimes draw, and it goes back to a lot of what people talk about in the SDN space, is that the ISPs, the core routers, your Cisco's, Junipers, Alcatel-Lucents, they're the underlay in this case, and they do the physical peering. They'll carry the traffic from one ISP or one region to another. The overlay is what we do with virtual routing in the cloud layer amongst the different cloud operators like Amazon or SoftLayer. And one of the important points to note is in order to really build this on a global scale, you have to be able to deploy in really any tier 1 or even tier 2 regional cloud operator in the world to give you scale, to give you your footprint, and to give you your reliability. And so this managed overlay creates linkages between the cloud operators, between the virtual routers, and it carries the user traffic. The analogy I was going to bring up is you look at what NSX, VMware does in the data center space as a managed overlay to the switches, within the data center. That's think of it as on a data center or on a campus level. We've basically extended that to the level of the global internet.
What are the, so what does that mean to scale out something like that?
Well, you have to be able to do a couple different things. First, as I mentioned earlier, you have the management agents or the measurement agents that will tell you congestion. So that helps inform where you put the virtual routers. But then you have to be able to quickly react to changes in traffic volumes, i.e., you may have, Sunday night between London and New York City, it's dead quiet. And then at the opening hour of trading, on the London exchanges, traffic volume goes up by 100 times for certain applications and services. And so if you're using this type of architecture for that type of service, you have to have a virtual router architecture that could scale 100 times in a matter of 15, 20, 30 minutes. This requires APIs into the cloud operators. It requires an understanding that if the capacity isn't available in AWS, you can immediately start provisioning in DigitalOcean or Google Cloud as an example. And you have to be able to, at the end of the day, linearly schedule and linearly scale with not understanding ahead of time what your volume of data is, what the state is of a cloud operator. And I'll go back to the statement I made about SDN. SDN has been pretty successful in closed environments within single operators or within data centers or within a campus, but it's a very different environment we're going into when you're looking across a dozen or more cloud operators across a larger number of potential customers and needing to scale up and scale down accordingly.
So I'm trying to think through then, in conclusion here, what are some of the ongoing challenges that Teridion faces when building out, these very sophisticated environments? What are some of the things you guys are trying to tackle right now? We're hearing more things about telemetry is becoming more discussed, right? Through basically kind of taking the data from all the machines, so to speak. We're seeing lots of use of the log data to do analysis to help better understand, behaviors and such. And I'm not sure that, that necessarily applies what you guys are doing, but those are big challenges in themselves. I'm curious on what your challenges are, as we start to think about kind of these giant infrastructures, almost as like these giant computers.
Right, and I think you hit it on the head, and in part of Jim's discussion, you hit it on the head. That once you have the basic scale-out architecture in place, once you have the management system in place, once your routing protocols at the cloud layer are working, the really big next nugget to address is understanding the telemetry, understanding the reporting, the visibility, and making best use of it. There are so many tools right now operating at different layers of the network and at different points of the network. I could probably, we're here, based, a block from South Park in San Francisco. Within a mile of here, I could probably find 50 companies in the network analysis and reporting space.
Mm-hmm.
And what we have to begin to do is make heads or tails of them. Which data can we use? Which data is best ingested? Which data has to be summarized and made available to the customers and their end users? And we're just beginning to hit on that now, and I think that'll be probably the most involved and the most rigorous job for us over the next 12 to 24 months. But I also think for the internet as a whole and for our customers, it's probably ultimately the most rewarding.
Interesting. So are those gaps that you're studying, Jim? Is that part of your own research? I'm curious what you're going to be think. Does this relate to what you're doing? And perhaps you can cite a few kind of examples of the challenges that you're seeing in the market and the larger trends that are being addressed.
Well, I think I was sort of hitting on it before, which is that I've covered this overlay network architecture, CDNs and other companies for quite some time. And traditionally, the way we've covered the issue is network monitoring and other application performance monitoring. That was on a different side of the house,
right,
for us as well. And the thing is, we need to find ways to tie these things together to properly address performance issues of, as you're calling it, the new stack, right? There's limits to the monitoring tools that we can use now. We could find ways to find out what's happening to our infrastructure, or a developer can, I should say. But wouldn't it be useful if there's a network issue that's affecting everyone in a particular region or a particular network? Are competitors experiencing the same issue because there's a coordinated DDoS attack on the banking industry? I think we start to think of ways in which aggregation of data from lots of these different sources, you're mentioning the word telemetry, network devices, servers, and other things, and gaining a deeper visibility by aggregating information from all these inputs. And, and I know Dave talks about this, and we've talked about this with other new wave monitoring firms, that we get to a situation where we have to leverage big data techniques to provide better answers to these performance and security problems as well.
And that's a great conversation for another day. I think we found our point of demarcation here. I want to thank you both very much for joining me on this show. This is new territory, and I think it's fascinating. I think this last part of the conversation we could talk about for quite some time, but I think I need to do some additional research in the meantime. But really, thank you very much, David, for illuminating some of these topics, and Jim providing that kind of thoughtful perspective that I think really is exemplary of this shift that we're seeing, where the developer is not, it's not just the developer, the operations person anymore. It's really is kind of like this thinking of the application and how it's developed and how it's managed, in these very complex, this very complex internet world and cloud services world that we're in. So Dave, thank you very much. Dave Ginsburg, Chief Marketing Officer at Teridion. Thank you very much for sponsoring this show and bringing so much to this conversation.
Thank you.
And Jim Davis of 451 Research, a senior analyst there, look forward to keeping in touch and learning more about this, this fast emerging space. So thanks for joining us.
Thank you.
These days, performance defines the success of an application. Teridion offers a new approach at how to get great performance with a new take on dynamic content delivery. Teridion makes files upload faster, web conferences run smoother, videos stream quicker, and applications pop, making your customers very happy. You can learn more at Teridion.com. That's Teridion.com. Thanks again, and I hope to see you back at the show. Bye-bye.